All right, so you want to, if you go to this cheat sheet, we'll see the unit circle. There it is in all its glory, right? We know the sine of 45 degrees. We know the sine of 60 degrees. So what's the sine of 105 degrees, right? And so because 105 is 60 plus 45, we might be able to say something about what the sine of 105 degrees is, and we know both 60 and 45. So that's what the sum formula is saying. What's the sine of alpha plus beta, right? If you know the sine of alpha and you know the sine of beta.
It's 6.2, right?
It is. And so here's the derivation. We're going to get this thing here. This thing, so let's suppose we take a rectangle. This is for acute angles to start. That's about as good as I'm going to do. Okay, what I'm going to do is this. I've constructed this rectangle with the following properties, that this thing here, that distance is 1, and it makes a right angle with this side, okay? Woo! Okay. Okay, and I want this angle to be alpha. And I'm interested in the sine of alpha plus beta, right? I'm going to make this angle here beta, right? And this distance is 1, right? I can make a rectangle like this. And I can put this triangle inside where that makes a right angle. Okay. I want to say something about the sine of alpha plus beta. There's some magic that's about to happen. Okay. We're about to perform a trick on you about the sine of alpha plus beta. Okay. All right. So now, this is a right angle. That's a right angle right here. This is a right angle, right? This is a right angle. Okay, and this whole thing here is a right angle. All right. So now, if this is 1, we know the y-coordinate here. What is this? What's the y-coordinate for this angle? What's this distance? If that's alpha, what's the height of this triangle? What is it? Let's call it z. We don't know what it is. Let's call it z. What do we know? If we know alpha, what trig function relates alpha to z in 1? Sine, right? We know that the sine of alpha equals z over 1. What's z? It's the sine of alpha, right? We're going to do that a lot. Z is the sine of alpha. What's this adjacent side going to be for the same reason? It is. Okay. I'm going to be using triangles all over the place. Okay. Questions about that so far? Is this the adjacent over the hypotenuse? Go ahead.
So automatically, oh yeah, the adjacent over the hypotenuse.
Yes, that's right.
So that's what it is.
That's it. That's what it is, brother.
So sine of alpha is the adjacent.
It's the opposite over the hypotenuse. Yeah, that's right. So this has to be sine because it's the opposite over the hypotenuse. That's right. I want to get some other sides together. I want this side right here. I want this side. Just this side. Okay. Now, what trig function relates beta to w and cosine alpha? Sine. The sine of beta equals omega over the cosine of alpha, right? Omega is sine beta cosine alpha. Omega is sine beta cosine alpha. If you multiply both sides by, so this side is sine beta cosine alpha. the sine of this angle is opposite, W, over this hypotenuse, cosine alpha. And now just solve for W. W, just multiply that there. W is sine beta cosine alpha. All right. Can somebody tell me what this angle is? Okay, so that's beta. That's a 90-degree angle. And this is some remainder, right? What's this? We don't know. It's a letter, actually. What do you think it is?
J.
So we can call it J if you want, but it's a letter we've already mentioned. Let's call this Z. Is that okay? Can we call? Well, let's call this M for the moment. Okay. I know that beta plus M plus 90. What is that? Is that okay? 180. Right? Because beta plus M plus 90 is 180 because it's a triangle, right? But now I'm going to call this S. I also know, what do I know about M plus 90 plus S? That's also 180. Right? M plus 90 plus S is also 180. So what's S? S is beta. This is beta. Right? That's beta, and this is also beta. Okay? For the same reason. So now I want to find this distance. Let me call that R. What trig function relates beta, the adjacent, and this hypotenuse? Beta, the adjacent, and the hypotenuse. What trig function is that? Cosine. The cosine of beta is equal to R over sine alpha. R is equal to cosine beta times sine alpha. Sine alpha cosine beta. Okay. One last thing. Can you tell me what this angle is? It's a transversal of two parallel lines of this rectangle. It's alternate interior angles. What's this angle right here? What is it? It's alpha plus beta. This angle is alpha plus beta because it's alternate interior angles, because these two lines are parallel and this is a transversal and alternate interior angles are equal. For the game, almost, this side right here, this entire side, I'm going to call that A for me. What's that side? Well, what angle relates alpha plus beta, its opposite, in this hypotenuse? Sine. The sine of alpha plus beta is A over 1. Now we're about to, all that stuff is up here. You don't need to memorize any of this. Okay? All right, so I've just done my job as a mathematician just now. I'm going to erase some things, and then we're going to see where the formula is. All right, what we've shown using a ton of trig. Are you ready? That part is sine alpha cosine beta. This part is sine beta cosine alpha. That's one side of this rectangle, and look at the other side of the rectangle. And of course, two opposite sides of a rectangle have to be equal. The sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. That's the formula. Okay. The sine of alpha plus beta is the sine of alpha, the cosine of beta, plus the sine of beta, the cosine of alpha. That's what we've just shown. So that's going to be the first sum formula that we're going to use. The sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. Thank you for being patient. So, yeah. I wasn't saying thank you for applause. I wasn't just like, ta-da! No, it's not doing that. No. So, okay. So again, sometimes I just got to show you why this is not high school. This is one of those moments. You really see this people in high school. Okay. So now, when I want to find out the sine of 105 degrees, we can do that, right? So then the sine of 105 degrees, the thing you want to do is you need to figure out what alpha and beta are. So alpha is 60, beta is 45, right? You can switch them if you want. But then this is going to be the sine of 60 cosine of 45 plus sine of 45, the cosine of 60. And we know all of that stuff because it's on the circle. All that stuff is on the circle. Sine of 60 degrees is the square root of 3 over 2. Cosine of 45 degrees is square root of 2 over 2. Sine of 45 degrees is the square root of 2 over 2. The cosine of 60 degrees is 1/2. Square root of 6 over 4 plus the square root of 2 over 4. So now using this formula, we're able to get more angles than just the angles on the circle, right, that are visible. There's going to be one for sine and one for cosine. Let's do one with difference. So if we do a minus instead, that means that the beta needs to be negative. Let's see what happens. So we got one formula. So we got the sine of alpha plus beta is sine alpha cosine beta plus sine beta, just switch them, cosine alpha. If you put a minus sign in this, sine alpha minus beta, then all that happens, because the sine is an odd function, is that a minus sign shows up. Okay. That's the next one. Then we'll do one for cosine. If you want to prove the formula for cosine, it's very similar. You construct this rectangle and go through a very similar argument like I just did for this one. The cosine one is that they're the same, each one. So it's cosine alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. And then cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. All this is on the cheat sheet in very compact notation. I'll copy it over right now to see how it looks on the cheat sheet. Cheat sheet is right here, it's right here, it's right here. These two things, they use the plus minus notation instead. Sum and difference formulas, that's what we've just shown. It was here, so they've written them in compact notation as two statements using the plus minus. So, but now they have a minus plus, so all they're saying is that if you have the sine of alpha plus beta, then you keep it as plus. If it's alpha minus beta, you use minus. If cosine of alpha plus beta, you use minus, and cosine alpha minus beta, you use plus. So they flip. So they have a minus plus, just where there was plus minus, just to say that the sign should be opposite. Right. So this is how they decided to write all four formulas just in two statements. With the sine formula, the signs stay the same. With the cosine formula, they're opposite. This whole section is just about using this formula over and over and over again. Let's do it. All right, going to the homework. Where did we leave off? Page 10, page 11. All right, those are the answers, 12, 13, 14. All right, cosine 45 minus 60. This will all be straightforward. Okay, so then zoom in, cosine 45 minus 60. All you need to do is go look at the formula, go to the cheat sheet, and see that cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. And in this case, it's pretty obvious that alpha is 45, beta is 60. And you just plug in the formula and use the unit circle. Okay. So this is going to be the cosine of 45, the cosine of 60, plus the sine of 45, the sine of 60. And it's all in a circle.
Put plus sine 45 degrees.
Yeah, now go to the circle. When you go to the circle, cosine 45 degrees is square root of 2 over 2. Cosine of 60 is 1/2. Sine of 45 is the square root of 2 over 2. And the sine of 60 is the square root of 3 over 2. Right? So the square root of 2 over 2 times, the square root of 2 times 1 is the square root of 2. 2 times 2 is 4. Plus, the square root of 2 times the square root of 3 is the square root of 6. And 2 times 2 is 4. I should take that. Have exactly try what you're doing. That's good. Questions about that flat out formula? Number 2, they're trying to actually say that this is the cosine of what angle? This is really just the cosine of 74 minus 29. Okay. What's alpha in this case? 74. Beta is 29. And write an expression as a cosine. So this is really a cosine of, what's 74 minus 29? 45. Look at that. Cosine of 45? Square root of 2 over 2. Say it again. Oh, so this is good. We were given this, and that one fits the cosine formula. Because it's cosine cosine plus sine sine. That's the cosine formula. If we go back up and look, I need to have these things close to each other. It's right there. They're trying to hide that one, right? Cosine 74, cosine 29, plus sine 74, sine 29. All right, that's page 14. 15. All right, identity. Now that we have all this new stuff, how do we show that sine of alpha plus beta over cosine alpha cosine beta is actually just tangent alpha plus tangent beta? We got one thing we want to turn it into 2. Let's just remember that the sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. Right? So it looks like we're going to turn, I think I'm going to have to take this to another page. Okay, so then add a page, we'll put it here. Okay, so then we'll start on the left. So this is equal to, so sine alpha plus beta over cosine alpha cosine beta is equal to, this is from, so these things are called sum and difference identities. Okay. The sine of this sum is the sine of the first angle, the cosine of the second angle, plus the sine of the second angle times the cosine of the first angle, all over cosine alpha cosine beta. And then we'll just divide separately, and then we'll see it, right? So then when you divide the first term by cosine alpha, this is equal to sine alpha cosine beta all over cosine alpha cosine beta plus sine beta cosine alpha all over cosine alpha cosine beta. Right, so you just divide each one of those terms in the numerator, and now things are supposed to cancel and the answer should arise, and that's exactly what happens. Right. We see that cosine beta and cosine beta cancel. You get sine over cosine, which is tangent. Cosine alpha and this cosine alpha cancel. You get sine beta over cosine beta, which is tangent. Right. So they cancel. You get sine alpha over cosine alpha plus, and then that's sine beta over cosine beta, and that is tangent alpha plus tangent beta. So the first one comes from the identity. So again, unfortunately, the more identities we add, the more identities we'll have to figure out. Let's see, that was page 14. Let's see what was it at the bottom of 14 or a brand new page? It was 13. Thank you. All right, so then we're gonna write, we're gonna do sine alpha cosine beta plus sine beta cosine alpha. And then you leave these denominators the same, cosine alpha, cosine beta, cosine alpha, cosine beta, right? The expression from the previous step then simplifies to tangent alpha plus tangent beta using what? Quotient identities. Expression from the previous step, right? Because then you should probably want to cancel. Oh, did they say simplifies? Yeah, it simplifies using quotient identities, right? Because sine over cosine is just tangent. All right, show this. Show that the cosine of x minus power 4 is negative square root of 2 over 2 times the cosine of x, the sine of x. All right, so again, we're going to write the identity. The cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Right? Alpha in this case is x. Beta is 5 pi over 4. Write the left side in terms of a sum or difference formula. That's exactly what we're about to do. You would write that this is the cosine of x. And the question is whether they want us to write the cosine of power 4. Okay, they do want us to write it. So cosine 5 pi over 4, and then plus the sine of x, the sine of 5 pi over 4. They want that. And then they say, well, now actually take the cosine inside of these things. So this is the cosine. You can write this in order. The cosine of 5 pi over 4. 5 pi over 4 is in the third quadrant. So this is minus square root of 2 over 2 cosine of x. And then this is also minus the square root of 2 over 2 the sine of x. Right? And then we'll factor it out, and that gives us that. The expression from the previous step then simplifies to this, hopefully just by factoring out, right? By the distributive property. Just flat out using the formula.
Distributive property.
Yeah, factoring out and multiplying back in, it's all just a distributive property. Yeah, so there is no property called the factoring property. We call it the distributive property both ways. So when I say that 3 times x plus 4 is equal to 3x plus 12, I can either say this is true because I factored out 3 from this, or because I distributed the 3 to both sides. And we prefer to say that this is true because of the distributive property. So you just have to choose. We can say that we started with this, factor out 3, you get this, or you can say I distributed the 3 everywhere here and I got this. We prefer to say that it's the distributive property. So if you don't see factoring here, but you see distributive, it's the same thing. Yeah.
It's not going to be the other.
You're not going to say the factoring property. Yeah, so this is the best choice. Yeah. Hang in there. Same thing. The question is, do I need to go through it? It's up to you. Sine of alpha minus beta, sine of alpha, cosine beta, minus cosine, well, let's do it, minus sine beta, cosine alpha. In this case, alpha is 180, beta is 45, and you use the circle. I'm going to leave that to you. Right? So you just do the same thing, fill it in, all those angles are on the circle. Sometimes they're just going to be not nice, and you have to find out your own angles. What's alpha and beta here? What two angles are 15 degrees apart that are on the circle? 60 and 45 work. There's another pair, 45 and 30. Either one should give you the answer, right? So you can write this as the sine of 60 minus 45, and then use this formula again, right? In the circle. What is this one trying to tell us? That's really the sine of what? Sine of 45 plus 45. Which is just the sine of, type of exact answer using pi as needed. Why are they switching to, they're trying to trick us, right? This is the sine of what? 90 degrees. Sine of 90 is 1 for sure. Questions there? So 17. Okay, so then there's one more identity for sum and difference, and it is, where are you, cheat sheet? There's one for tangent. Oh, it's, where's the cheat sheet?
All the way down.
Down? There it is. Here's the one for tangent. Alright, so the tangent yeah, right here. The tangent of alpha plus beta is tangent alpha, and the signs match, plus tangent beta, at least they match in the numerator, and then they're backwards in the denominator, 1 minus tangent alpha, tangent beta. Okay, the proof of this, this is up for debate. All right, so the proof of this goes like this. We know that tangent alpha plus beta, here is the proof super quickly. Tangent alpha plus beta, what's tangent? Sine over cosine, right? Sine over cosine, and we conveniently have those two formulas right here, right? So that's equal to sine alpha cosine beta plus sine beta cosine alpha all over cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, right? So those come right from the identities that we came from these two, and then we'll divide the numerator and denominator as you might expect, because this is a 1 you're going to divide the numerator and denominator by this. Right? So dividing everything by that, you get sine alpha cosine beta all over cosine alpha cosine beta plus sine beta cosine alpha all over cosine alpha cosine beta, and then you're going to get all over cosine alpha cosine beta all over cosine alpha cosine beta, and then minus sine alpha sine beta all over cosine alpha cosine beta, right? So you divide everything by this thing. This turns into 1. What happens here? That's the tangent of alpha, right? This cancels, that turns into the tangent of beta, and this is tangent alpha, tangent beta, right? And that's exactly the formula there. Okay.
Wow, we got a lot of
Okay. What'd you say?
we got a lot of stuff to do.
No, no. You don't have to memorize any of that.
Oh.
I'm just showing you why it's true, that formula is true. That's it. Okay. And so the one with minus follows the same way. Okay. So for this one, you're just using that formula. I do not have this one memorized at all. I always have to look this one up. So I probably won't even test you on this one. For the homework, what page is that? 15, 17? Yeah, so it was 17. Yeah, so then this one is really, I think it's tangent of, so it's tangent of 10 plus 35. We still have it here. Yeah. Tangent of alpha plus tangent of beta is going to give you tangent of alpha plus beta. And so this is just a tangent of 45 degrees. Look at the circle. The tangent of 45 degrees is 1. They want to do all this stuff in radians now, right? It doesn't matter. Looking at the formulas, this is just a sine of 7 pi over 12 minus pi over 12, right? That's the sine of 6 pi over 12, but that is just the sine of pi over 2. And we're looking at the circle, the sine of pi over 2 is 1. This is the sine of pi over 2 in all reality, and that is 1. So again, what we're doing is making sure that you can see that there are all sorts of ways of manipulating trig functions, right? And in your work, you shouldn't be surprised that when you work with trig functions, you might not get the exact answer, but it might just be what we expect it to be. The sine of pi minus theta is actually the sine of theta for every theta. Right? We're going to use this formula again. Sine of alpha minus beta is the sine of alpha cosine of beta minus sine of beta cosine of alpha. And in this case, alpha is pi, beta is theta. And let's see if this actually comes out. When we substitute in, the only thing that should be left is the sine of theta. Sine of pi times the cosine of theta minus the sine of theta, the cosine of pi. Write the left side of the identity using this and do not simplify. So this flat out goes here. This goes right here. So star, that goes right there. The expression from the previous step simplifies the sine of theta because of what? You're just using the circle. No identity is required to evaluate the, yeah, that's right. So the sine of pi is what? What's the sine of pi on the circle? 0. 0 times cosine of theta. What's the cosine of pi? No, it's -1, right? It better be if we need a positive. So no identity is required, you just evaluate the thing.
So is it cosine?
0 times cosine is 0.
The sine.
And then it's negative sine theta times negative 1, which makes it positive sine. Okay. Excellent. We are almost there. Same thing for tangent. So again, I gotta remember this formula. Let's see if I got it. Tangent of alpha plus beta. Whew. I think it's tangent of alpha plus tangent of beta all over 1 minus tangent alpha tangent beta. So therefore, in this case, alpha is 2 pi, beta is theta, and we're just plugging in. It's the tangent of 2 pi plus the tangent of theta all over 1 minus the tangent of 2 pi times the tangent of theta. What's the tangent of 2 pi? Tangent of 2 pi is 0. This is equal to 0 plus the tangent of theta all over 1 minus 0. This is the tangent of theta. And so the expression from the previous step, so what do they want us to write here? Write the left side of the identity using either the sum or difference. So they want this, I think. The question is, do they want it simplified? Try just this, right? So that over that. And then it simplifies the tangent using, I don't think you need an identity. You're just evaluating. Questions there? All right, here we're just going to use the identity again. Sine of alpha minus beta, sine alpha cosine beta minus sine beta cosine alpha. Right. Write the fraction from here as a difference of 2 separate expressions. So they just mean divide individually. Sine alpha cosine beta over this thing, cosine alpha sine beta. And then minus sine beta cosine alpha over cosine alpha sine beta, and then divide out any common factors in the previous expression. So then this leaves tangent alpha cotangent beta, right? So sine over cosine is tangent, cosine over sine is cotangent, and that's flat out the same thing. Right? Sine beta cancel, cosine alpha cancel, and you have it. The expression from the previous step then simplifies to this. I'm worried about, they actually want us to leave it. What do they want us to do? No, they want this to simplify to this. What step do they want us to write? Rewrite the fraction from the previous step. It says do not simplify. So we put this here, right?
Yep.
Then what is it? Then divide out any common factors in the expression. So then they don't want this yet. They don't want this yet. They want us to just divide these out and get 1. And then they want sine alpha over cosine alpha. Let me get the eraser. They don't want you to apply the quotient identities yet. And so again, yeah, this is the technicality stuff. They want you to leave this like this. And then you're using quotient identities to write the conclusion. And then, okay. This is going to be the next identity, actually. The sine of 2 times, these are called double angle identities. The sine of 2x is 2 sine x cosine x. Cheat sheet. The cheat sheet on this page?
Yeah, right under 24.
Yeah, cheat sheet. Sine of 2x, where are you? Sine of 2x. There it is. Sine of 2x is 2 sine x cosine x. All right. As I said before, all the other formulas are going to come from these. Right? Here's the derivation. It's sine of 2x is the sine of x plus x. We know the sine of alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. And now alpha and beta are both x. So this is going to be sine x cosine x plus sine x cosine x. That makes two of them. No identity for that. And just add. I think this is for the game. All right, for the game, I'm going to tell you that the sine of alpha is 4 over 5, the sine of beta is 15 over 17, and you're just filling it in, right? There's nothing to do. So we'll just write out the formulas, and you just put these numbers in and simplify the fractions. This is the cosine of alpha, cosine beta, although they're being bad because you've got to find the other ones. Sine alpha, sine beta. This one is sine alpha cosine beta plus sine beta cosine alpha, right? And so they gave you sine of 4 over 5, the sine of alpha and the sine of beta. So you just need to take the time to find the cosine of alpha. So what's the cosine going to be? We know it's, what triangle is that? Blank 4, 5. Get the triangle together. 4, 5. I'm sorry, 5 is the hypotenuse. What's this side? 3 for sure. Okay, so cosine alpha is 3 over 5. You just have to check the sign. What quadrant are we in? Quadrant 1. Is it positive or negative? It's positive, okay. This other triangle that we're talking about for beta is 15 is the opposite, 17 is the hypotenuse. Blank 15, 17?
16.
Let's do it. Z squared plus 15 squared equals 17 squared. Z squared plus 225 equals 289. Z squared equals 64. Z is 8. 8, 15, 17. Okay? So that means cosine is 8 over 17. Just got to check the quadrant. This is in quadrant 2, so this needs to be negative. And now you got every single one of them. And you just plug in and deal with the fractions, right? How would you do this one? You got two choices. I could go back and look at that formula, right? Or I could take this and divide it by this. Tangent sine over cosine. Okay. All right, well, in there, a bunch of stuff, right? Lots and lots of stuff, okay? So next week, we'll just barrel through. We're going to get every formula on that sheet, and then we'll get this test and get out of this chapter as quickly as possible. So we'll do that. Yeah.
You're taking
on next Tuesday?
Tuesday at midnight. Thursday at midnight?
Like Thursday?
I can do that. That's a
I
lot.
didn't do it last one yet. I had work.
Okay. We'll talk. It's too bad that you're the only one working in the world.
No, it's not. I work hard, baby.
I know.
We're going to take a test thing.
Yeah, I'm going to look at test stuff right now. Let me stop the recording.